So after studying the type of triangle, let's move on to study certain theorems. Theorems of triangles. First we start with BPT, basic proportionality theorem. Now line DE is parallel to line BC in triangle ABC. Then what can you say? Then you can say that AD upon DB will be equal to AE upon EC. Okay, that is your basic proportionality theorem. How do you get the proof? By similarity. Proof is not required, but the result is. So remember BPT. Next, interior angle bisector theorem. As the name says, it's an angle bisector. Something that you see in a red is an angle bisector. We have studied median, we have studied altitude. Now the new is angle bisector. It just bisects the angle. So if the angle is 60, 30 will be bisected. Then you have AB, which is one side, upon BC. AB upon BC will be equal to AE. A, which is the side on which the angle bisector is coming, is divided. A and then EC. So angle bisector of any angle of a triangle divides the side opposite to the angle. The side opposite to the angle is divided in the ratio of remaining two sides. So remaining two sides are AB upon BC. On the side opposite to the angle bisector, AE upon EC. Okay, AC is divided by A and C. Let's go on to the next theorem, which is midpoint theorem. So midpoint theorem is just like your basic proportionality theorem, but in this case D is a midpoint of AB and E is a midpoint of AC. D is just parallel to BC, just like in BPT. But in this case, D and E are midpoints of the two sides of the triangle ABC. Then what do you say? DE, which is parallel to BC, is half of BC. So if BC is 10, D has to be 5. Okay, proof again by similarity. Let's go to the last, exterior angle bisector theorem. Now what is this? Triangle ABC, exterior angle, if you can see in this case, is angle DBC. The angle bisector, what is it stating? The angle bisector of an exterior angle DBC, angle bisector which is drawn in the white. The angle bisector of any exterior angle of a triangle is ABC, divides the side opposite to the angle, So which is my exterior angle? DBC. What is the side opposite to it? Check it. What is the side opposite to it? AE. Okay, it will divide AE externally in the ratio of remaining two sides. So what are the remaining two sides? Apart from AC, it's AB and BC. Right, in the ratio of remaining two sides. So write first remaining two sides, AB upon BC, right? That will be equal to what? The side opposite to the angle bisector, AE upon CE. So A is divided in the ratio of A upon C. So remember this exterior angle bisector theorem as well. Similar to your interior angle bisector, the side opposite to the angle is being bisected. And the last of which we'll see is Apollonius principle, or also called as Apollonius theorem. When will you remember this? When there is a median. Okay, what is a median? Median divides the opposite side into two equal parts. It bisects the opposite side, right? So if there is a median in triangle ABC, then what can we say? Sum of squares of any two sides of a triangle. Okay, so two sides I'll take AB and one side I'll take AC. So two sides of a triangle is equal to what? Is equal to twice the sum of squares of median. Okay, sum of square of median. What is median in this triangle? AD. So is equal to twice the sum of square of median, and then what? To the third side, and the median to the third side, and the square of half of the third side, right? This is equal to sum of what? Median square plus square of half of third side, which is my third side BC. What is half of that? BD or DC, right? Because the median has bisected, BD is equal to CD. So write any one of them. I'm writing here DC or CD. Okay, that's it. That is your Apollonius principle. Okay, now let's apply this. I'm being given here a figure in which I've been said AB is parallel to CD. Okay, AB is parallel to CD and BC is parallel to AD. BC is parallel to AD and BC is given to me as 16. So AD will also be equal to 60. Now this is forming what for me? A parallelogram. Opposite sides are parallel and equal in parallelogram as a figure. Now you will study this in quadrilateral. We will start in the next part. In parallelogram, the diagonals always bisect each other. Okay, remember that. We'll study this in quadrilaterals. In parallelogram, diagonals always bisect. So I am being given here what is AC 20. So it will bisect into 10 and then 10. Okay, so now for this, I know this is how the figure looks like. I'm being asked what is BD. So even if I know what is BO or DO, I'll do twice of that and that will be my BD. Now let's just consider this triangle, the one which is being made in red. This is a triangle. Yes, triangle what? DBC, in which CO is a median because it is bisecting. Okay, CO is bisecting your DB, so CO is acting as a median right now. If there is a median, I can apply Apollonius principle. What? One side square 18 square, second side square 16 square is equals to twice of median square. What is median? 10 square plus 1 half of the opposite side. Half of the opposite side is nothing but BO. Okay, so BO square, that's it. 324 plus 256 is equals to 2 into 100 plus BO square. Now I'll just solve this. Just add 256 plus 324 is equal to 580 is equals to 2 into 100 plus BO square. So 580 divided by 2 is nothing but 290 is equal to 100 plus BO square. So BO square is equals to 190. BO will be equal to square root of 190. So I got one part which is BO, but BO is equal to DO because diagonal bisect. So that will be also equal to square root of 190. DB, which is being asked, is 2 into square root of 190. That is how you apply Apollonius principle. Okay, so remember all the theorems.